Hello, everyone. Just going to go through a couple things in regards to downhole electronics today. What I'll do is I'll give you a quick introduction to who we are as a company, some background on downhole electronics. Definitely something that's key to everyone in that area is quality, reliability, and then how we can address quick response and what our downhole division does. So DSM as a company, we are basically an electronics manufacturing company. We specialize in downhole electronics and service kind of the industries in regards to medical, military, industrial control, and communications. We've been around for 12 years, so started up in 2000. Certification-wise, we are an ISO 9001 and 1345. Our specialties are quick-turn prototyping, volume manufacturing, and our downhole tools. When it comes to electronics downhole, there's definitely some key factors you need to consider when you're designing and building these type of products. Obviously, three key ones are temperature, pressure, and the stress that these things are under in the operating conditions. Quite often, the devices that are going into these products are not intended to be used at these operating conditions. So there's a lot of testing that has to go on to qualify these devices to operate in those conditions. Really key as well is the layout and design. You need to be able to design this thing properly to mitigate field issues. And also key is you need to build more than one of them most likely, and how do you do that? So what is really high temperature? It means different things to different people. Right now, typically things are tested and built to stand up to about 150 degrees C downhole. We're seeing basically today and forward right now, we're seeing some of our customers pushing the 170 to 175 degree range downhole. We're anticipating the next kind of year to year and a half to 2 years, we'll see that push up to 225 degree downhole temperatures. Really, and then going beyond kind of into the 3 to 4 year time frame, we're seeing 300 degree plus in what we're seeing from our customers. Products that we've seen so far, there's really two main areas of downhole electronics that we look after, and that's in the well logging drilling world, and then the monitoring tools that stay downhole for a longer period of time. Your well logging and drilling tools are typically downhole hours to days at a time, whereas your monitoring tools that are sitting downhole in applications with their steam assist, those could be down there for days, months, years. And those are the devices that are typically approaching the 300 plus range in operating temperatures. This is really kind of the new frontier when it comes to downhole electronics, and a big key driver in this is going to be micro nanotechnology. To get the devices smaller, you're dealing with extreme heat dissipation issues downhole, and how do you make sure these devices can operate at that length of time frame? Quality side. Key is actually designing in the quality of the product initially. You can only design in quality and reliability. You can't manufacture it in. We typically manufacture products in IPC Class 3 guideline. What we work with our customers on is making sure they design to those guidelines as well. The device testing and classification is obviously very key. Like I touched on before, how do you make sure this device works where it shouldn't? And repeatability. How do you actually build more than one? How do you make sure that you can build, they all work the same if you're going from 1 to 5 to 10 to 100 different tools? Where we step in with this is how we can help people along this path. As we get involved in the prototype stage, we will help customers in design for manufacturability, design for testability reports, and making sure their product can be built and built repeatably. We leverage our existing experience that we have. We've been doing this for years and years, downhole electronics, and quite often there's things that we've seen that work well that others may not have thought of. We have a wealth of knowledge when it comes to different high temperature solder alloys as well. We've experimented and run many programs with some very, very high temperature solder alloys that are very unique in this industry as well. And what we pride ourselves on is automating the entire assembly process. The only way you can actually get repeatability is to actually automate it. We don't hand assemble any boards. They're all machine placed. And all the algorithms and profiles are all basically pulled up. So every time we go to build a product, we have a specific recipe we can pull back up for that product to build it the exact same the second time, third time, fourth time. From the quick response side, we do have a quick turn prototyping line. We do 3 and 5 day turns in that line. We actually get down to 24-hour turn if it's really needed, but it gets really, really expensive. What we want to do when it comes to doing prototyping is do 2 things really. We want to prove in the concept of the design for the customer, make sure the product's supposed to do what it was designed to do, and then obviously prove in the manufacturability of the product. Can it actually be built again? Key is obviously making sure the customer has the product when they need it, and that's where the quick turn comes into play. And building the product with automated placement equipment. When you're hand soldering a board in a lab, as you're touching a soldering iron to a specific part, you can't really control the temperature putting onto that part. It can be overstressing the part and not even knowing it. When you're putting it through the automated assembly process and running it through the reflow ovens, there's a specific profile that follows that board all the way through. It's temperature controlled, the speed that's in there, all is controlled. And it can be repeated over and over and over. So from the downhole side, what we do is offer basically full electromechanical assembly right from the PCB level to complete tool integration, putting the boards in the tool, wiring it, potting it, and testing it. So definitely, in order to do that, you need a strong understanding of where these tools are used, how they're used, and knowing what the operating conditions are of them. One thing our organization has had since day one is a strong commitment to the quality. We've never had a downhole tool ever returned to us from a customer. It's never failed in the field, and that's key, absolute key. Downtime in the industry out there is measured in the hundreds of thousands of dollars an hour, not the tens of thousands. And then testing and thermal burn-in. So we do have the capability to test these products, burn them in at a certain temperature. We can test them at operating conditions, basically. Any questions? Quick and to the point.